All right, what we're going to do here is we're going to graph a secant function. We're going to identify the period and vertical asymptotes and phase shifts and vertical shifts as well, if there are any. So first off, when we have a secant function, in my previous video I did one with secant, cosine, and sine, and so on and so forth. For secant, it's important to understand what is the basic secant or cosecant function, I'm sorry, which is really 1 over sine. And so when you think of 1 over sine, we have some vertical asymptotes. And the vertical asymptotes occur whenever sine equals 0. And so if we look at our original value, I'm going to put this little 0 there. That means original. All right, so that means original. All right, so whenever you see me see that, that's my original function. And for sine, when does sine start equaling 0? Well, that actually starts at 0. Very similar to when you have a cotangent function. And so right here at 0, sine is going to be 0, and therefore we have a vertical asymptote because it's going to be the denominator. We could then go down and go pi over 2. That's going to equal 1. We would go back to pi. Pi will give you 0 and the denominator as well, so it's a vertical asymptote. We go to 3 pi over 2, 3 pi over 2, which will give us -1 for sine, so we can plug sine in there. And then we have 2 pi, which will equal a vertical asymptote as well. As you can see, where do we have vertical asymptotes? Well, vertical asymptotes are happening at every pi value. So vertical asymptotes, we can call them VAs. We would write the equation at n pi. So every pi, all right, every pi, n being an integer, we're going to have a vertical asymptote for cosecant, or whenever you have 1 over sine. Well, what do we do then? Well, our period for a cosecant, just like a secant function, our period is 2 pi. All right, its period is 2 pi. So it repeats every 2 pi going through the cycle. All right, so that is the basic cosecant function. Now, how does this one change? Well, whenever you figure out transformations, you always look at their original and you manipulate it. So how is this changing? Well, let's look at the x's first. Well, our x's, okay, how are our x's changing? Well, how is this changing from the original? So I'm going to say this x of zeros. So all these values, if I want to have this, I would set it equal to the inside because that's what changes the inside. Notice I do have a b value and I do have a c value-ish right here. And so what happens there? Well, I'm going to set that equal there and find out what I have to do to get and solve my answer. So first thing I'm going to do is let's add pi over 4 over here. So we're going to have right there, and we're going to add pi over 4. And then right here, we're going to divide by 2 or multiply by 1/2. And so that is what we're going to do to get our new x values. Our y values, it appears that our y values, we're just going to be multiplying over here by 3, okay, because it's the outside, here's my a value, and whatnot, okay? So for each one of these values, I'm going to be adding pi over 4, and then multiplying that by 1/2. And so for our first one, I plug in 0 into here. 0 plus pi over 4 is pi over 4 times 1/2, which gives us pi over 8. Pi over 8. Now that's important because since we're starting at 0, we realize we actually have a phase shift. Okay, a phase shift. So always look at your 0. All right, where is 0? All right, we have a phase shift in this function. Sometimes they call it PS. All right, this is going to the right. All right, pi over 8 units. Pi over 8 units. You can identify that by taking this value right here, and if you factor it out, you'll get that phase shift value, okay? And when you solve for it, so get pi over 8. From here, we can find the remaining portion, okay? We take pi over 2, add pi over 4. That's going to give us 3 pi over 4. And we multiply that by 1 over 2, so it would be 3 pi over 8. 3 pi over 8. We can take pi plus that is going to give us 5 pi over 4. 5 pi over 4 be 5 pi over 8. 5 pi over 8. We go into another one. All right, 3 pi over 4 is going to give us 7 pi over 4. 7 pi over 4. Okay. Yep, 7 pi over 4 times that would be 7 pi over 8. And you can see a little pattern forming here. All right, because we're going to go 1, 3, 5, 7, and the next one probably notice is going to be 9 pi over 8. 9 pi over 8. If we put 2 pi, all right, that would be 9 pi over 4 times 1/2, which would be 9 pi over 8. 9 pi over 8. For each one of this, we're going to take this and multiply all our y values by 3. Well, vertical asymptotes aren't changed by any changing because it's 3 times the vertical asymptote is a vertical asymptote. So right here, 3, we have 1 times 3, all right, or 3 times 1. And what we have then is 3. We take our vertical asymptote. Once again, we have another vertical asymptote. -1, 3 times -1. All right, which is going to equal -3. And then we have this one right here, vertical asymptote. Okay. Once again, how are we finding these values? I'm taking each corresponding value right here, because you may not have been very clear. All right, and I'm just plugging that in to the x sub 0. So I'm taking 1/2, and I'm going to take, like, for example, pi over 2, all right, plus pi over 4, and that's what gives me that 3 pi over 8, and so forth. Okay. Do we have a vertical shift? Because one of our problems here, do we have any vertical shifts? Well, we do not have any vertical shifts. Okay, I'm going to call it VS. None, because that would be the D value. All right, none. All right, there is no D value. We're not adding, not adding, not adding to function. All right. Okay, we're not adding anything on the outside of the function. And so we have that there. Okay, well, let's graph this real quick. And I'm going to change the color and I'll make this green. And so when we graph this now, what does this new function look like? This new function looks like, all right, well, we can go by pi over 8 probably if we look at it this way. So we have pi over 8. All right, so every pi over 8, so that'd be 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8. And so right here, this would be 3 pi's over 8. This would be 5 pi over 8. All right, 6, 7, 8, 9, 9, 10, 11. We can just keep on going on and so forth, and we can just have that. All right, I'll go by ones, 1, 2, 3. All right, we'll go by -1s as well. And so here we go. So our first one is going to be a vertical asymptote. Okay, right there. And we have another at this one, we have 3. So we'll just put that there. At 5 pi over 8, we're going to have another vertical asymptote. And at 7 pi over 8, we're going to have -3. Okay, and then we have another one at 9. All right, another vertical asymptote there. And so what's happening, this is going to go up like so. This can go down like so. All right, and that's what we have for our graph. And we would repeat over and over again. For our period, because we probably want to write this out. So what is our period here? Well, our period we know we can find by taking 2 pi over b. All right, because 2 pi is the original period of the secant function, and b, we do have a b value right there. And so what we realize is that our period is going to be 2 pi over 2, which is going to equal pi. How can you verify this? Well, if you take the bottom value, just to verify, okay, another way of doing this is, you don't have to do this, but I'm like just showing all the tricks of the trade, and you subtract that from the end to the beginning of those different values. All right, what you have then is, all right, what is that value? That's its period. Well, that'd be 8 pi over 8, which is actually going to equal pi. So we did verify that this is pi. Vertical asymptotes. What are we doing with vertical asymptotes? Well, if you have this right here, okay, where's our first vertical asymptote? Our first vertical asymptote is at pi 8, all right? And if you notice what is happening each time, well, normally, all right, what we have right here is going to be n pi. Well, now it's going to be n right here, n pi over 8, all right, n pi over 8, and that is going to be our vertical asymptotes. All right, so every n pi over 8, we have that. So or is that going to be true? Let's just think about this. And there. All right. Um, so it'd be 2 pi over, no, that doesn't seem to be correct. I'm sorry. All right. And so what is happening here? I apologize. All right. What do we have then with this? Well, let's just figure this out. So if x equaling pi is our normal value that we were looking for, all right, that's our original. I just go like that. We can actually solve this, all right, by actually doing the same thing that we did over here. Since we have that right there, we know that we are doing some transformations and shifts. And so what is happening here? Well, we're going to take this and we would have 2x minus pi over 8. That's going to equal n pi's. All right, and we're going to solve for x, this new value here. And what we do is, all right, and we just put pi there. And what we have then is we're going to take our pi over 4, and we're going to add that to the other side. So we have pi plus pi over 4. Okay, and then we have 2x. And by going through this little process, we'll see we have 3 pi over 4, 3 pi over 4, and that's going to equal 2x. And so then we go to the next one is we divide by 2. All right, divide by 2. And then we have is 3 pi over 8, 3 pi over 8. Okay, and that makes sense. And so every n of 3 pi over 8, that's where we get our values. Okay, so every multiple of that. So if you had to 2, 1, 2, 3 pi over 8, that's what we have there. And then every one going from here, and I am getting really mixed up on here. I apologize. Oh my goodness. All right. But our new vertical asymptotes are going to be from here, and each one is going to be, oh man, oh golly gee willikers. Okay. It's going to be a total of pi over 2 units away. Is that correct? So if we have pi over 8, and we're adding a pi over 2, all right, and what would that be? Adding pi over 2 to that, and that's going to be 4 or 5, yeah. Right. 2, 4. And that's where we go. Oh my goodness, and that's horrible. All right. What we have right here is we are starting at pi over 8. And then we're going to be actually changing it up because we're no longer right here. So what is the distance from here to, all right, this value, all right, between each vertical asymptote? And we realize that we're going to be pi over 2. All right, pi over 2 is this distance. And so every n pi over 2, we will get another vertical asymptote in this particular case for this particular function, all right, of cosecant. Sorry about that and all my confusion. Sorry. All right, so in any case, this is how you do cosecant. We found our vertical phase shifts. We found our vertical shifts, which we didn't have any. We graphed this out. I showed you again how you can take your original function and create your new function by solving and setting those equal. Found our period, our new period. Right here, and we found our vertical asymptotes. All right, vertical asymptotes. In this case, generally you start with your this, and then you find the distance between each one, and that will be your n plus n there. I should have started at the beginning. Sorry about that. Hope this helps you out. Sorry, don't give me a dislike. Hopefully you like the majority of this video, and good luck and God bless.